Swayam Prabha. Digital India. Educated India.
Welcome friends to this last module of this online NPTEL certification course of environmental soil chemistry, and in this last week or last module we are going to talk about the analytical techniques for assessing soil pollution. And so these are the concepts which we are going to cover in this week. First of all, we are going to talk about briefly about the soil analysis and how soil analysis is being done, and what are the choices of the techniques, what are the considerations for selection of the techniques, then how to prepare the samples, the sample preparation steps, and then we will be talking about the determination of different types of inorganic pollutants. Among the inorganic pollutants, we are going to cover the nitrogen, then phosphorus, then different salts and trace elements. So, we are going to cover all these, and then once we covered the determination of inorganic pollutants, we are going to cover the organic pollutant, determination of organic pollutants like pesticides, then hydrocarbons, then volatile and semi-volatile compounds and humic substances. Remember, soil is contaminated, soil is called contaminated when it is having higher concentration of either inorganic pollutants or organic pollutants or both of them, which causes significant health damage for the human being and also creates hazard to the environment. So, to determine whether a soil is really contaminated or not, you have to employ or you have to adapt certain methodology for error free or accurate measurement of different pollutants. And in this chapter or in this module, we are going to discuss all these in details, and then we are also going to discuss the different analytical techniques. For example, in case of nitrogen, what are the different forms of nitrogen, inorganic nitrogen, and how we generally measure those different forms by different instruments. We are going to have a brief overview of all the instruments which generally are being used by the scientists in advanced soil characterization laboratories. So, let us start with the concept of soil analysis. Now, soil analysis are very significant because they are the basis for important decisions as regard to crop management and environmental monitoring. Remember, the soil testing has to be done both from the point of view of crop management, because you have to understand the soil fertility property, and simultaneously you have to understand whether your soil is contaminated or not with certain inorganic or organic pollutants. So, to serve both this purpose, you have to do soil analysis with the sophisticated technologies. Remember, one key factor which influences the quality of the soil analysis is the sampling procedure and subsequent soil preparation. We are going to discuss them in details in the next couple of slides. So, soil analysis are very significant, and we have to do this soil analysis both for maintaining or monitoring the soil fertility status as well as to monitor the soil environmental contamination or soil pollution level. Now, there are several methods or several techniques for soil analysis, numerous techniques. Now, based on which points and which criteria we should select the most appropriate technique for certain soil analysis. Soil has different parameters. For example, we can measure the soil pH, soil electrical conductivity, soil different nutrient content, different heavy metals, different organic pollutants also. So, depending on different pollutants, we have to consider certain key points before selecting the most most feasible technology. Now, the first point is the selectivity of the the sensitivity of the technique. The technique which you are going to follow for measuring certain soil parameter has to be highly sensitive. If it is not sensitive to that particular soil parameter, this is of no use. So, the sensitivity of the technique is very important. Whether there is a change in the concentration of a particular pollutant, if the method can identify that change, then it is called the sensitive technique. Now, the specificity of the resulting signal. Now, one common problem for most of the instruments which we use for environmental analysis, environmental sample analysis is the samples are, since the samples are complex in nature, their signals are also complex, and it is difficult to identify the proper signal which you can particularly assign to a particular soil property. So, it is a basically mix of different mix of signals from different fractions or different pollutants. So, the specificity of the resulting signal is very important, and you have to identify, okay, this is the signal which is responsible for this particular pollutant. So, unless you do not get this particular resulting signal or specificity of the resulting signal, you cannot understand any particular pollutant. So, the specificity of the resulting signal is another important issue. The accuracy of the calibration, whether you do any type of analysis, the calibration of the instrument is the most important thing. If the calibration is wrong, then the results are wrong. So, the calibration is one of the most important process of measurement. For every analysis, you have to calibrate the instruments using the prescribed steps, and most of the instruments require their calibration before their run, and most of the instruments require everyday calibration. Some instruments require calibration after certain samples. So, their frequency varies from one instruments and one technique to another technique. However, the calibration is universally required for all the instruments which we are going to use, for which we are basically using for measuring different inorganic and organic pollutants. Now, the specific cost effectiveness is another important issue. There may be numerous solutions for a particular problem. However, we have to select the one which gives the best possible solution with the reasonable cost. So, depending on your budget, you can select the most cost effective method for determining the different pollutants. Although the high valued instruments are laboratory standards and they are very accurate to measure the pollutant levels for different purposes. However, due to the budget restrictions, sometimes you have to go with some cost effective instruments for measurement of different inorganic and organic pollutants. The fifth one is specific purpose and the parameters to be determined in the analysis. So, this is another very important, specific purpose and the parameters to be determined in the analysis. So, all these 5 factors are important to make a choice of soil analysis technique. So, you cannot neglect any of them while selecting them for soil analysis. Now, what are the general common instruments for different parameters in the soil, for measurement of different parameters on the soil? So, spectrophotometry is a common method for determination of phosphorus and mineral nitrogen in the soils, and I have produced here this is an UV based spectrophotometer. So, this UV based spectrophotometer is used for measuring different soil parameters. Now, apart from that, flame atomic absorption spectrometry is also used for determination of alkaline earth metals and transition metals like copper, zinc and manganese. Flame atomic emission spectrometry is basically used for alkali metals. ICP-AES, the full name of ICP-AES is inductively coupled argon plasma atomic emission spectroscopy. And this is the technique which we use for measurement of boron, silicon, aluminum and traces of some pollutant mineral. And in case of toxic organic molecules, we generally go with this high pressure liquid chromatography or HPLC with a suitable detector, for example, mass spectrometer. So, these are some of the general instruments which you can see in most of the soil characterizing laboratory. So, their specific purposes are also given. However, there are also certain instruments which we are going to cover in this module, which will show their usefulness for measurement of these different parameters. Now, apart from these instruments also, there is a attachment called auto sampler. Now, this auto sampler is basically an attachment for automated measurements. Now, automated measurements are easy to implement in soil analysis nowadays, and most measuring instruments are equipped with the automatic sampling system. As you can see here, it is an auto sampler of atomic absorption spectrophotometer. So, these atomic absorption spectrophotometer can automate the sample the sample analysis without any human intervention, substantial human intervention. So, all these instruments which we use nowadays, all the sophisticated instruments like ICP-AES, like atomic absorption spectrophotometry, all these are having their auto sampler attachment, which can help for automated aspiration of the of the chemical from different wells or different solutions. So, this is the auto sampler. This is very important. Now, let us consider very important part, that is sample preparation. Now, a good and reproducible and accurate measurement of pollutant always depends on good sample preparation. If your sample is not well prepared, then your results are also meaningless. So, the conditions under which the soil samples are stored and treated can have a strong effect on the results of their analysis. If the soils are not properly processed and stored and treated, the results will be erroneous. So, generally for environmental monitoring purpose, we use generally tightly sealed containers to avoid evaporation losses. Also, samples should be stored frozen at 0 to 4 degree centigrade in order to avoid changes induced by microbial action, and analysis should be performed as expeditiously as possible after samples have been collected. So, if we collect the samples and keep it in high temperature, obviously microbial activity will increase, and as the microbial activity will increase, obviously there will be changes in their physiochemical and biological properties of the sample. Now, to stop that microbial activity, generally the scientists keep the soil samples tightly in the vials for 0 to 4 degree centigrade and store them, and analysis generally done as soon as possible after samples have been collected, so that no substantial changes are occurred. Now, remember that the most samples reach the laboratory in field moist conditions. So, this diagram basically shows in details about the different steps of sample preparation. So, let us consider that a field moist samples with a weight of greater than 500 grams has been collected. So, once we collect the soil sample, the next important step is to describe the sample. Without description of the samples, we cannot, it is meaningless, because we cannot go back and see the same site and check whether there has been any change in the pollutant concentration or not. So, the sample description is also needed for identifying the root cause for these pollutants. So, the sample, once you do the sample sample description, now the next step is the drying of the complete samples. Now, drying of the complete samples you can do do this by air drying, and also you can dry it in the freeze dryer. We will discuss freeze drying, and also you can dry it in the oven. Now, in the oven, when you dry, after you dry the after you dry it in the oven, you can do the you can remove and the gravels and grass roots and other debris from the soil for subsequent for further analysis. Now, once you sieve out all the gravel, glass, roots and other artifacts from the soil, then the next step is to sieve the material, specifically soil. Now, the soil is generally considered as the material which has less than 2 millimeter particle size. So, sieving is generally done to ensure that the particle size is less than 2 millimeter. Now, after you sieve, you can keep it with more than 2 millimeter or fractions of less than 2 millimeter, and then the fractions which are greater than 2 millimeter, you can further crush them to less than 2 millimeter by milling process, and the clods can be further crushed and further mix, and those fractions which are less than 2 millimeter can be mixed well. So, the clods, if there is no clods, then we can just generally weigh and store. So, this is how we start with the field moist samples, then we do the sample description, then we generally dry the complete samples. After drying the complete samples, we generally remove the artifacts and gravels, glass and roots, and then we sieve them to to keep less than 2 millimeter. When the fractions are greater than 2 millimeter, we crush them and then further mix them. We weigh them. After we weigh them, then we can do the subdividing of the samples or subsampling the sample by the hand quartering method. We will be discussing the hand quartering method, or by using different types of sample divider or subsampler. This sampling divider are used for laboratory samples of around 200 grams, and subsamplers are generally used for archiving the samples, and then the laboratory samples can be subdivided by hand quartering or by sample divider or by subsampler, and mass for analysis is generally less than 2 gram, and then we can do for further milling of less than 250 microns, which further gives you the test samples. So, if the mass for analysis is less than 2 gram, then further milling is done to get the test samples. If the mass for analysis is not less than 2 gram, then we further go for the test samples. Consider this as a test samples. So, we will discuss all these steps in the subsequent slides. So, the most soil samples are reached into the laboratory in field moist condition. So, the first step to be taken is thus to dry them. We have already covered the drying of the complete sample. However, remember that complete drying. So, sample should be allowed to dry in the air at a temperature never exceeding the 40 degree centigrade. We generally want to maintain this 40 degree centigrade, so that there is no substantial changes in the organic matter, because soil contain organic matter. If you increase the temperature, the soil organic matter will be oxidized. We do not want that. Or organic chemicals or organic molecules which are present in the soil can be oxidized if we increase the temperature. So, that is why we generally maintain the temperature of 40 degree centigrade. However, remember that drying can alter the chemical and physical properties of the sample. So, the drying temperature also can affect the nitrogen and phosphorus measurement. So, drying has a profound influence in the soil testing. We can either dry it in the air, which can which can more or less maintain the original composition. However, when we dry them in the oven, there is a chance of degradation of soil organic matter or organic pollutants. Now, so once we dry the soil samples, the next step is to removal of the gravels. However, for drying, you also remember one important thing, that there is certain metalloids or organometalloid compounds, for example, arsenic, then mercury, then selenium, they can easily lost by air drying also. So, air drying, while it is known for keeping the original chemical and biological composition intact, certain these metalloids, organometallic compounds like arsenic, then mercury, selenium, they are easily lost by air drying also. So, for this generally we go for the freeze drying or lyophilization process. So, freeze drying of the sample is therefore often required to ensure the accurate determination of this species. Now, freeze drying, also known as the lyophilization or cryodesiccation, it is a low temperature dehydration process. So, what happens in this freeze drying? So, it is a low temperature dehydration process that involves freezing the product. So, basically we freeze the product, lowering the pressure and removing the ice by sublimation. So, this is in contrast to the dehydration by most conventional method that evaporates water using heat. So, here we convert the moisture by removing the ice by sublimation process, and this is an example of a freeze dryer which is used to freeze dry different materials. So, samples which contains, so samples which we generally use for measurement of organometallic compounds of arsenic, mercury and selenium can be freeze dried for their long term storage without their loss in air drying. So, this is a lyophilizer. Now, once you dry the samples, you remove the artifacts, then next step is crushing and milling. Now, crushing and milling generally is done for keeping the sample size, for keeping the particle size of less than 2 millimeter. Now, according to ISO 11465, a 2 gram subsample is large enough when its particle size is below 2 millimeter. So, when the particle size is below 2 millimeter, then 2 gram subsample is enough for doing the analysis. However, milling is done when the test sample is less than 2 gram. So, when there is a test sample which is less than 2 gram, then generally milling is done. Why milling is done? To further decrease the particle size, and generally the size in the milling process goes below 250 micrometer. So, here you can see this is a this is a miller, and this is used for milling the soils. So, we have collected the soil, we have we have described the soils, then we have dried the soils, and then we are doing the crushing. After we crush the soil, then we are going to sieve the soil. Now, sieving can alter the chemical composition of the samples also. Remember that in order to avoid the contamination, it is prudent to use plastic sieve rather than metal sieves, although metal sieves are more hardy than plastic sieves. However, in case of plastic, there is no chance of contamination from the metals which are present in the metal sieves. So, this is an important point when you should consider while sieving the samples. Now, once you sieve the samples, you must have got enough samples. So, to store the samples for longer duration and to better utilization of the space for storing, you have to subsample the collected sample. Now, for subsampling, generally we follow a method called quartering process. Now, in the quartering process, you can see first we make a heap of the soil after we sieve them. So, it is forming a cone, and after we form a cone, we generally make it 4 quadrants. So, the opposite quadrants are basically discard, as you can see here. The opposite quadrants are basically discard, and by discarding the opposite quadrants, you keep the rest 2 quadrants and then mix them together. So, by using this method, you can reduce the sample size for efficient storing. And although this method is known as quartering process, in case of mechanical subsampling, you can use rifle boxes. So, after you subsample, after you produce a subsample, you can store the sample for variable time period. Dry soils should be stored in a relatively dry place to prevent the absorption of atmospheric moisture. So, after you do all these different processing, you can store the samples for longer duration of time for future analysis. So, we have covered the choices of techniques, criteria for the choices of the techniques, and then sample preparation. Now, let us start determination of different inorganic pollutants. So, for discussing this, let us start with the nitrogen. Now, inorganic nitrogen in soil occurs predominantly as nitrate and ammonium ions. Now, nitrite is generally very rarely present in detectable quantities. Generally, in the soil, nitrate and ammonium ions are present. Now, for most of the soil testing laboratories, when we talk about the available nitrogen, we generally test the nitrate concentration. However, in case of forest soils, the laboratories generally measure both the nitrate as well as ammonium ions also. Remember that for measurement of the concentration of a particular ion, you have to add certain extractants. Some of the extractants are, for example, in case of nitrates, some of the extractants are, for example, saturated calcium sulphate 2H2O, then 0.03 molar ammonium fluoride and 0.015 molar H2SO4, 0.01 molar calcium chloride, 0.5 molar sodium bicarbonate, 0.01 molar copper sulphate. So, all these are generally used as an extractant for nitrate, and 2 molar KCl solution is the most widely used extractant for nitrate and ammonium. So, these extraction, once you extract the ions from the soil using this extracting solution, you use different types of instruments for their measurement of this concentration of different ions. Now, we are going to discuss about the analytical methods for inorganic nitrogen. The first tool which we generally use for determination of inorganic nitrogen or particular ion is ion selective electrodes. Now, these ion selective electrodes are basically membrane based electrode that measure a specific ion, for example, nitrate in an aqueous solution. So, after you extract that nitrate into an aqueous solution by using some extractant, then you can use this membrane based electrode or ion selective electrode, we sometimes call it ISE, to measure the specific ion concentration. Now, when the membrane of the electrode is in contact with a solution containing the specific ion, a voltage dependent on the level of that ion solution develops in the membrane, and that is why we can measure that ion concentration. So, this is basically the principle of this instrument or this tool. It is a membrane based tool. So, when we dip it, the membrane of the electrode come into contact with the solution containing the specific ion, and then when it come into contact with the specific ion, a voltage gradient, a voltage difference occurs depending on the concentration of the ions and develop across the membrane. So, which can be further measured. Now, so this is the basic principle of this ion selective electrode. Now, this ion selective electrode is used to measure the concentration of nitrate in aqueous samples, and it is simple and inexpensive analytical tool. However, it requires frequent calibration. As I have mentioned, that calibration is very necessary before you go for any analysis. So, similarly, in this case also frequent calibration is needed for this ion selective electrode. So, guys, let us wrap up our lecture here, and we will start from here in our next lecture to see what are the other analytical instruments which are available for measurement of inorganic nitrogen, and also we will discuss other instruments which are which we generally use for measurement of other inorganic pollutants in the soil. Let us wrap up our lecture. Let us meet in our second lecture of module 12. Thank you very much.